Hello everyone. In this lecture, we will study one of the most important and dominant element which is involved in the analysis of translational motion systems, that is the mass, which is represented or denoted by M, capital M. Now here, mass is a property of the system which stores the kinetic energy of the translation motion. So mass can store the kinetic energy, and here the mass, it has no power to store the potential energy. So these 2 points are very important, that is mass will store the kinetic energy and it has no power to store the potential energy, and it is measured in kilograms. And the displacement of the mass, it will always takes place in the direction of the applied force, and then that will result in the inertial force. Okay, so here whenever you apply force on a mechanical system, that is whenever you apply a force on a mass, so the displacement will takes place in the direction of the applied force, and that will result in inertial force. So here the force will be proportional, that is directly proportional to the acceleration. Okay, so the inertial force, that will be always proportional to the acceleration, which is produced in the mass m, okay, capital M, by the applied force. Now here consider this figure. In this figure you have a mass m, and it has zero friction. Okay, here it is indicated that it has zero friction by these two rollers, and you are applying a force F of t. Because of this force F of t, there will be a displacement x of t. You can see the direction of the displacement is in the direction of the force. So always the direction of the displacement will be in the direction of the applied force. Now here you can write the force which is required. It is proportional to the acceleration. Okay, so here force F of t, that can be written as m into acceleration. Now here we have written force is proportional to acceleration. We can remove the proportionality sign and we can take a proportionality constant here, capital M. So F of t will become m into acceleration. Now acceleration is what? It is double differentiation of the displacement. Displacement is x of t. The double differentiation of the displacement is the acceleration. So F of t is equal to mass into acceleration, that is equal to mass into d square x of t by dt square. Now if we take the Laplace of this, we can write it as f of t become f of s, m remains as it is. So the Laplace of this, it will be s square x of s. Fine. Now we know that mass, it cannot store the potential energy. So there cannot be any consumption of force in the mass. Okay, so mass cannot consume any energy. Okay, any energy or force, it cannot consume any force because here it cannot store the kinetic energy. Because of that reason, it cannot consume the force. That is, suppose here if you have two masses m1 and m2. Now here these masses, these are connected to each other as shown here in the figure, and if you are applying a force F of t here for m1, on m1 you are applying the force F of t, there will be a displacement of x of t for m1, and there will be same displacement x of t for m2 also, because here the force which is applied to m1, the same amount of force will be applied to m2. Why? Because here m1 will not consume any force. Why? Because it doesn't store the kinetic energy. So due to mass, okay, due to mass, there cannot be any change in the force from one mass to another mass. Therefore, there will be no change in displacement. Suppose here if this m1 has consumed some energy, then less energy would have been applied to m2 and there would have been change in the displacement. But because the force, that is the amount of force which is applied on m1, will be equal to the amount of force which is applied on m2, because of which there will be no change in the displacement. Fine. So the displacement of a rigidly connected is always same. This you have to remember, this point you have to remember, that whenever two masses are connected by a rigid body, you apply a force, there will be no change in the displacement. Okay, this is very important with regard to the mass. If you find this easy and helpful, please don't forget to like, share and subscribe, and see you in the next video. Thank you.